Hi, everybody. I'd like to spend a little bit of time going through some images of tables and figures from some of the papers we've been considering in this course with an eye to looking at best practices for creating your own tables in R. So we're going to start with some of the balance tables. So if you recall, a balance table has the mean for the um, what we often call the control group, and then the mean for the treatment group. In this case, it's slightly different, but the idea here is we'd have two columns, one of means for the control group, one of means for the treatment group. And then we might have a third column indicating the difference between the two means and whether a t-test of the difference in means results in rejection of the null hypothesis that the means are equal. If the means are equal, the difference is very close to zero. If we can reject that null hypothesis, so we say the means are different. And we often use a shortcut for representing that rejection of the null hypothesis by simply putting asterisks indicating the degree of statistical significance of the t-test that we're conducting. And if there's three asterisks, that means that we reject the null hypothesis at the 1% level. Um, so the p-value is less than 0.01 for the test of the difference in means. So that's the basics of a balance table. Notice the title here. We have the table and its number, colon, and then a descriptive title. So that's the way most titles for tables should usually be run. We might have a subheader here, like here's the list of the variables. Notice that the variables are rewritten not as their variable names, but rather as a very descriptive short label. So the reader understands what the variable is. Notice that the person has carefully put 0 ones for dummy variables so that you know that these are all dummy variables, whereas this is a continuous variable, and this is a continuous variable, and this is a continuous variable. And notice that they've put the units of the measurement here. At the bottom, in every table, we should always have an indicator of the number of observations in that the table is based on. And very often we'll want to have a note at the very bottom indicating some aspect of this table. So that's the first one. Let's move on to, we'll get faster as we go into subsequent ones. So let me go down to the next one, if I can, there we go. And let me annotate here. So we have our second table. Again, a table with the number, colon, and then a description of the table. Baseline characteristics, pretty straightforward. Treatment group, control group. This person has the number of observations as the first row in the table. Again, nice descriptions of the variables rather than the variable names themselves. A good long note that explains all of the construction of the variables, what the variables mean in the table. And we also have then the p-value here in the final column. So no asterisk, just the p-value, and we see that none of the p-values are lower than 0.10, the 1 star, or 0.05, 2 stars, or 0.01, 3 stars. So in this case, we don't reject any of the null hypotheses that the treatment group is different from the control group, which is as it should be in a randomized control trial. If we have sufficient sample size, they should, by the randomization, have roughly equal means before the treatment has taken place on variables that are measured before the treatment. So that's another one. Let's continue on. And let me clear. And so here's another very similar table. Here the person has put the table number above the title, sample characteristics and balance across study arms. We have, in this case, three study arms, one, two, three treatments that the experiment conducted. So there's three columns. There's number of observations in each, and then the variable names, and then the summary statistics, the means for the variables, along with asterisks indicating differences. And here they give the explanation of what the asterisks are in terms of p-values for the t-tests. You can only do a t-test of differences in two means. So each t-test is relative to the delivery mean. So there's no asterisk on the delivery column because you're not testing this against itself. You're testing delivery against home sales and delivery against vouchers, whether the means are different. I like this table also because they carefully specify what's the unit of observation for these different variables. Some of them are at the household level, some of them are at the individual child level, and some of them are at the community health worker level. So they make that clear in the table. Let's go on. Here's another balance table. I won't, this one's a little busier, right? A little harder to read, but you see again, a nice table number, the description of the table, the means of the control and treatment and the entire sample, the number of observations, a long footnote that tells you what, a note in the table that gives you explanations. So nice balance table. And here's again another balance table. Again, the variables, the number of observations, treatment group. Here they've separated the treatment group into participants and refusers. So in this case, this was the UN paper. They know who refused to take up the grant after the first round. And again, some of them are percentages, some of them are continuous variables. So a nice table. And let's see, was yet another baseline table, existing firms, treatment group, control group. Yeah. So those are examples of baseline tables. And here's a figure from one of our early papers that we read. So notice again that we have the figure and the number. Normally we'd want to have colon here. That's sort of standard practice. And then we have a very descriptive, comprehensive title of the figure. And then we have some notes at the bottom of the figure indicating the source and a variety of other notes. We have a legend here in the figure. So I've been encouraging you, this legend, since there's so much white space in this figure, would have been easy to move this legend into the figure, which then would have had more, the figure itself would have been bigger. Right now, almost a third of the figure area, if we think of all of this as the figure area, almost maybe not a third, but a fourth of it is the legend, whereas there's plenty of room in the figure to have the legend, for example, right here. Your figure then is bigger, and it's probably more easy to read the legend anyway if it's in there. Personally, I'm not a fan of this gray space around the figure. I think figures look better without this gray space, and this figure's generated in Stata, the other software that economists use. In R, you've seen how you can set the theme and have theme minimal and not have this kind of gray area around the figure as part of the plot. So there's a decent figure. Let's go on to another figure. Did I skip one? Yeah. Here's the figure that you had for the assignment. And I wanted to draw attention to the importance of labeling the axes, the importance of having a subtitle, but don't make the subtitle be the same thing as the main title. That's obviously pointless. So make sure that your subtitle is informing the reader of something. The title should say figure 7, this, that, or the other. This subtitle might expand or add more information to that. Here's the legend in this case. Very important that the legend title actually tell you what it is, not just that there's two groups, but what the groups are. And of course, 0 or 1 has kind of a particular meaning for us. We know 0 means you didn't get it, 1 means you are in the category. But the for ease of the reader, it'd be better to replace the 0 and the 1 with what those categories actually are. 0 being control group, 1 being treatment group. And that's pretty easy to do that in R as part of the ggplot options, to have the 0 and the 1 actually be the labels of the groups. So there's a lot you can do to improve this graph, and many of you did good jobs on improving it. So we'll go on to another graph. So this is a line plot. This was from a paper that we read very early in the quarter. And again, we have the figure number with the colon and descriptive title. Notice how in this one, there was no need to put a legend, because we could, the figure was so simple that we could just put in text by annotating. So we use text annotate to put in text onto the graph itself, and just through trial and error, figured out where to place the text so that it's next to the line. So it's even easier to read without a legend. So not very hard at all to do that kind of change in a figure. And here's a nice table of the outcome variable, the returns to fertilizer. So we have the mean and the median and the standard error of the estimate of the mean, of the sample mean, and the number of observations. And for each treatment, A, B, C, and D, we have a description of what the treatment is and what their means were. What this table doesn't have is whether the means are different across the treatments, and whether those differences are statistically significant. But the reader looks at this and sees, well, these differences are quite large, and the samples are reasonably large, 100, 200. So by knowing what the mean is and the standard error, you can look at the two means and see, wow, the mean here, for example, is 28. The mean here is 47, is 20 higher. The mean here is 63, almost 35 higher, and the standard error is only like 7. So of course, those are going to be statistically significant differences in means between these two means. So that's a table of just the mean outcomes. We're usually interested in regression estimates of the outcomes. So here's a table. I think this could be improved. Table 2, main results. I think they could have been more descriptive about what it is that the table is describing. But in the context of the paper, we know that the coefficients here is estimating what the impact is of the treatment on the outcome of either program maze, total maze output, or profits in this case. Notice that they have indicators for what the other control variables are. In the note, they indicate what all the control variables are. They have the number of observations. They give the control group mean in the table. They have actually two panels here, right? Panel A and panel B. It's a little hard to do in R, so I'd encourage you to stick to one table and then have the second, instead of having panel A and panel B, just have table 1 and table 2. But if you want to explore how to do that in R, it's certainly possible to have a multi-level table like this with different panels in the regressions. Okay. So the rest are very similar tables. Notice that every column has a descriptor of what the basic outcome variable is for that column. So that's very easy to do in Stargazer. Notice that this table has both a descriptor and a number for each column. So that's really nice for the reader, especially when discussing it with other persons, to be able to say, look at column 7. Instead of saying, look at the under 5 mortality regression results, and then which one? The number 4, number 7. So having the numbering there really helps. So again, number of observations, R square, extensive notes. So a good table, the model of the table. Here's a much more complex, busy table, right? Kind of hard to read. Maybe they could have broken this down into 2 separate tables to make it easier to read. They're really compressing a lot of information into the table. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 outcome variables and two different kinds of regressions, so two panels. Quite a lot of information. A simpler table with a lot of explanatory variables. Here's where, you know, many of these explanatory variables are not of interest to the reader. This is an estimate of the training effect. So many of the explanatory variables, as you notice down here, they're not significant, and you know, the reader isn't really interested in them. The reader's certainly not interested in the intercept. So this table could have been made a lot more compact simply by omitting the results of those explanatory variables and putting it in the notes that these were additional explanatory variables. And maybe if it was relevant to note whether the Ashanti ethnic group was important for some reason, then they could have noted that in the records, in the paper or in the notes. Let's take a quick look through a couple others. Nothing particular to note here. Notice again that the variable names on the left-hand side are all not the variable names, but rather a descriptive label. And that's easy to do in Stargazer to replace the variable name with a descriptive label. Just look at the Stargazer options. And that's it. So I hope this was useful, and I look forward to seeing your tables and figures as you work through your papers.